Okay, dear students, today we are going to discuss Newton's law of gravitation. So, Newton's law of gravitation. We all know Sir Isaac Newton was a great scientist and he formulated Newton's law of gravitation. The statement of Newton's law of gravitation is the gravitational force of attraction existing between any two masses in the universe is directly proportional to the product of the mass and is inversely proportional to the square of the distance between their center. So this statement I would like to translate mathematically. So according to Newton's law of gravitation, there is a body of mass m1, there is another body of mass m2. These are two bodies, and if these two bodies are d distance apart, then there exists a gravitational force of attraction between them. The gravitational force of attraction, I have represented that force of attraction by F. The gravitational force of attraction is directly proportional to the product of the masses. The mass of this body is m1, the mass of this body is m2, their product is m1 into m2. So gravitational force of attraction is directly proportional to the product of the masses and inversely proportional to the square of the distance between their center. Inversely proportional to the square of the distance between their center. So this is what I stated in Newton's law of gravitation. Now I want to express this law mathematically. So in order to express this law mathematically, what I need to do? I need to combine these two proportionalities. So when I combine them, I will get m1 into m2 over d square. m1 into m2 over d square. Now, as we know, if you want to remove this proportionality sign, we have to introduce one proportionality constant. So the proportionality constant here I am going to introduce is capital G. Capital G is a proportionality constant, m1 into m2 over d square. So what is the value of capital G? What is the value of capital G? This capital G is called universal gravitational constant. Universal gravitational constant. Sir Isaac Newton was not able to calculate this value. Sir Isaac Newton was not able to calculate the value of capital G. Instead, the value of capital G was calculated by Henry Cavendish. It was calculated by Henry Cavendish. Henry Cavendish is the same guy who discovered hydrogen gas. Now, in SI system of unit, the value of capital G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. 6.67 into 10 to the power minus 11 Newton meter square per kg square. You can see it is 10 to the power minus 11. So since it is 10 to the power minus 11, its value is very, very low. It has a very low value, and the low value of capital G is responsible for the weakness of force of gravity. It is due to this low value of capital G, gravity is the weakest force, or gravitational force is the weakest force in the nature. So from this discussion, here I have derived a very important formula. This formula, F is equal to G m1 into m2, G m1 into m2 over d square. This is very important. I will be using this formula many times in our further discussion. Now, after this, I would like to continue the discussion with gravitational force. Now, inverse square law. So what does it mean? And why Newton's law of gravitation is called inverse square law? Now that is a very important topic I would like to discuss here. Here you can see gravitational force of attraction between any two bodies is inversely proportional to the square of the distance between their center. It means that here are two bodies The mass of this body is m1, the mass of this body is m2, the distance between them is d. The distance between them is d. Now, if I double the distance between these two bodies, now what I am doing? The distance between these two bodies is 2d. In that case, how is the force going to change? How is the gravitational force going to change? We can see, since force varies as the inverse of square of distance between the two bodies, the force will decrease by 4 times here. The force will decrease by 4 times. So because of this peculiar nature, Newton's law of gravitation is called inverse square law. And it is a universal law. It is a universal law. So what does it mean? It is a universal law means this law is applicable anywhere. Everywhere in the universe this law is valid. This law is valid here on the surface of the earth. This law is valid even in the center of the earth. It is valid even in the moon. Anywhere in the universe this law is valid. So it is called universal law. And more important topic, gravity is the weakest force in the nature. Gravity is the weakest force in the nature. Gravity is the weakest force in the nature. Moreover, gravity is always attractive. It is always attractive. Gravity is never repulsive. Now, I want to give you an example. Just like gravity, we have another force that is called electrostatic force. Electrostatic force is the force which exists between charged particle, positive charge and negative charge particle. Electrostatic force can be attractive, it can be repulsive also. If there are two similar charges, the electrostatic force is repulsive. But if there are two dissimilar charges, the electrostatic force is attractive. Unlike this, gravity is always attractive. Another very simple example we can give, magnetic force. Magnetic force is sometimes attractive, sometimes repulsive. If the poles are similar, magnetic force is repulsive. If the poles are dissimilar, the magnetic force is attractive. Unlike that magnetic force, gravitational force is always attractive. So, even though it is the weakest force in the nature, even though gravity is the weakest force in the nature, since it is always attractive, and when huge mass is collected, at the time the effect of gravity is seen. A big effect of gravity is seen. If you want to test the effect of gravity, you can feel your weight. The mass of the earth is 6 into 10 to the power 24 kg. This is the huge mass. So this huge mass has produced the effect of weight in our body. This huge mass has produced the effect of weight in our body. So these are some of the key points while discussing Newton's law of gravitation. I would like to revise a bit. Mathematically, Newton's law of gravitation can be expressed as F is equal to G m1 into m2 over d square. It is a universal law. It is applicable everywhere. It is always attractive in nature. It is always attractive in nature, and it is the weakest force in the nature. It is the weakest force in the nature. So this comes under the introduction of gravitational force. Now I would like to dig deeper into the mathematical formula which I have derived. So mathematically, Newton's law of gravitation can be expressed as F is equal to G m1 into m2 over d square. So what is G? I told you already, G is universal gravitational constant, and I told you its value also. Its value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. So what does it mean? What is the physical significance of this statement? What do you mean by G is 6.67 into 10 to the power minus 11 Newton meter square per kg square? Now that we are going to understand. Let us take two bodies. This is M1, this is M2. Suppose M1 is 1 kg and M2 is also 1 kg. M1 is 1 kg, M2 is also 1 kg, and suppose the distance between them is 1 meter. Now what I am going to do, I am going to plug in this number in this equation. This is equation 1 for the time being. So when I plug in all these values, what I will get? F will be as it is because I don't have the value of F. G will be as it is. I don't have the value of G, but I have the value of M1. M1 is 1 kg. Similarly, I have the value of M2. M2 is also 1 kg. And I have distance 1 meter square. So 1 kg into 1 kg into 1 means numerically this all is going to be 1. Numerically this all is going to be 1 means in this situation F will be equal to G. So what does it signify? It means that if I am able to calculate the force of attraction between two 1 kg masses, if I am able to calculate the force of attraction between two 1 kg masses when they are 1 meter apart, then whatever the value of force I will get, whatever the value of force I will compute, that value will be equal to capital G. So numerically in this situation, F will be equal to 6.67 into 10 to the power minus 11 Newton. This is the force existing in this situation, and it is this very force which is numerically equal to universal gravitational constant. And Henry Cavendish performed a very delicate experiment, and by performing that delicate experiment he was finally able to calculate the value of capital G. Now some characteristics of capital G I would like to discuss. I told you already, it is a universal constant. Capital G is a universal constant. Universal constant means it is constant everywhere. Its value does not change from place to place. It is a scalar quantity. It is a scalar quantity. It is the gravitational force of attraction existing between two 1 kg masses which are 1 meter apart. So this is the discussion, introduction of gravity. I would like to conclude my class here up to this much. For further, please you please be in contact. We will come with more videos. Thank you.